I'm giving a talk today on Stuxnet. So it is a worm that was designed to damage Iranian centrifuges to slow their nuclear research. Common conspiracy theory is that it was Israel and America, the governments, that came together and made this. Why we're talking about this one in particular. This is the first worm that was created that actually caused physical damage in the real people world. And it was about 20 times more complex than anything seen up to that point, which is why it's commonly believed that it was developed by governments. And it was also transferred without the use of the internet, which was unseen before. So the three things that it did: it looked for Microsoft Windows machines, and then it looked for that box, the Siemens Step 7, in order to compromise its PLU. Guess what a PLU is? It's a programmable logic controller, which pretty much means that it regulates everything in a system. So the main one that they were looking for was for this nuclear power plant. So this particular PLC controlled where oil went and what pipes were open and how fast things spin and how the air conditioning worked, all that kind of stuff. So it did this, and it traveled from computer to computer until it found this particular box. And how it did that was it traveled through USBs. So the USB would get plugged in, and it would see if this was the right computer. And then it would go to the next one. And it also traversed through the local networks, utilizing 0 days. And what are 0 days, you may ask? 0 days are a vulnerability in software that is unknown to the developers. And these are sold on the black market for about $100,000 each. Stuxnet, anybody know how many they had? 20. 20 of them. So that's a lot. That's a lot of holes that this system had that they could go through. All right, so the general structure of the program. It was a DLL file, so an executable, that was stored in a wrapper. And then, so this file was extracted into the memory and made into a module. And then there was a pointer to that file that was passed as parameters into various modules. For all those of you that know words. But what it actually did is this. So it stayed in the system and just held everything normal for 13 days. And then it did something really weird for just a couple of minutes, like 2 or 3 minutes. It made the centrifuges really, really fast or really, really slow. And then it would go back to normal for 27 days. And it would repeat steps 2 and 3 until everything broke. So, but it did this without telling the people that were sitting at the computer screens watching it that anything was wrong at all. And that's where it really got everybody, because the people that were watching these screens thought that it was purely a technical malfunction. They just had no idea what anything was going wrong. Oh, that's not the right size. Okay. Cool. So, yeah. So mitigation strategies. This is a really common study that people look into, and it's been going on for years. And they've all come to the conclusion that there is no single solution. It's a combination of prevention and reaction for the parties involved. So prevention-wise, they decided that you really need to have policies and procedures set in place so that you know what you're going to do if anything happens. And that they need to raise security awareness within the company so that you know that you shouldn't have USBs going between every single computer, because that's bad. And not using USBs, again. And regularly updating systems, because that's where it really got it. And then reaction-wise, that when you see the actual problem happening, don't wait around and let it get bigger. and that you should really filter communication to the localized area to try to get it better, and to really have a plan in place. I guess that's the main point here. To get rid of something this big, there needs to be a plan. Cool, so the really scary part. You can go to GitHub right now and download this whole program for free and edit it however you want. And that's really scary because all of you could really do this. Don't do this. You have an ethics class telling you not to do this. So yeah, we're kind of just, it's kind of a waiting to see if anything bad happens, because there really is no real way to stop this from happening again. Yeah, so that's the general idea. Yeah.
Well, I mean, surely now that we know exactly how it did what it did.
We don't, though.
Really?
Yeah. There have been thousands of analysts looking at this thing. Nobody has cracked it. It happened in 2010 was when they found it, after 9 months of it running. And to date, nobody has cracked it. Yeah.
When you say cracked it, do you mean de-obfuscated it?
I don't know that word.
Oh, yeah.
Is that what I mean?
Yes.
Yes. Amongst other things. Yes.
Where did they get the source code?
The source code? I don't really know. I think it was posted.
By who?
I have no idea. We can look.
It might just be decompiled though. That's the second batch. Which is probably why people don't know what it does.
Right.
Yeah. It's
Thousands
decompiled.
of lines of x86.
Really inscrutable.
Well, I'll do it.
Yeah.
Okay. Yeah.
It just de-encrypts itself and then runs what it just took out of the data section.
Cool.
And
Yes.
then also there's going to be a bunch of other machine code for the different architectures, like the machine code they inject on the microcontrollers that control the thingies, centrifuges. That's not going to be x86.
It's a fun word. Centrifuges.
Centrifugal.
Yeah.
So, if you know how many 0 days there were in it,
It's an approximation.
okay, so they can't identify.
They've officially counted 13.
Okay, but those 13 have been patched, right?
Yes.
But they know that there are.
But they know that there are more. Yeah.
So there's 20 is sort of an estimate.
20 is an estimate. Yeah.
Oh, it's not scary.
Yeah. Yeah. Any other questions? Yeah, sure, go for it.
So how does this affect us?
So, yeah, no, that's the really scary part. This could be used, this code right here could be used to shut down this whole building, this whole city. Not as is, but it could be altered, and there are people out there that could alter it. Yeah. Okay, yeah.
Under prevention, they could have also not used Windows.
Answer number 1, don't use Windows.
Actually, I do have a question. So
Yeah.
this is just an issue with Windows system. Any Unix-based system wouldn't have to worry about this problem.
From my research, yeah.
Well, there could be other 0 days.
Yeah, there are, yeah.
Obviously, I mean for this specific.
If I ran on your thing, it would be Also, wait, how many 0 days did you say that?
About 20. Why did you find a lower number?
Yeah, the article I was reading claimed like 4, but I think that's
I mean, when was it written?
2010.
Yeah, so that was right when the virus was like found.
So it's at least 4.
Yeah,
So it's somewhere between 4.
yeah.
It could be more than 20. I mean, 20 just means...
I got my number from a 2014 academic journal, so
Well, it's
I'm just saying.
with 4, they were like,
Yeah, that's a shit ton. Yeah.